Okay, in the last class we have seen the general fragmentation rules and the representation of the mass spectrum and everything. That's what we have seen. The basic introduction regarding the mass spectrum, and that we discussed last class. In today's class, we see the general fragmentation, modes of fragmentation. So in a once if a molecular ion is formed, and how this molecular ion undergoes the fragmentation, and so there are types, and here these are the types. One is simple cleavage, second one is the rearrangement reactions, that is the rearrangement reactions which occurs by transfer of atoms, and the other one is okay so these are the two main things of modes of, here you have that in mass spectrometry fragment. So first one is the, here if you see that simple cleavage. Under simple cleavage, what you have under simple cleavage, you have homolytic cleavage, heterolytic cleavage, and retro Diels order reaction. So retro Diels order reaction also you can is a, you can call it as simple cleavage, but it comes under rearrangement also. You can call it as a, and Diels order reaction you have seen Diels order reaction, and it is opposite to that Diels order reaction, retro Diels order reaction. Next one, rearrangement. One is scrambling. Okay, another one is a Mcclafferty rearrangement, and third one is elimination. So by these processes, the molecular ion may undergo the fragmentation to give various fragments. So these fragments can be charged, or they can be neutral, or these fragments can be radicals. And only thing here you have to understand that, remember that only charged fragments, charged ions will be detected by the mass mass spectrometry detector. It will not detect any neutral fragment or radicals. Only charged one, either it is a positively charged or negatively charged, either it is a molecular ion or it is a fragment ion. So coming to the homolytic cleavage. So homolytic cleavage, here it is a cleavage anyway. Cleavage is the redistribution of electrons. Either it is a transfer of one electron, transfer of two electrons. In homolytic cleavage, if you see that, you will have the transfer of one redistribution. Each, distribution of electron still there. So only one homolytic means you know that. Okay, so transfer of one electron, here it will be to each of the fragment. So each of the fragment will get one electron. So that's what here we have the homolytic cleavage. You can see the example, how the cleavage happens. So this is a distribution. Each fragment will get one electron. So you will get one positively charged, another one you will get the radical. The next one is the heterolytic cleavage. So heterolytic cleavage, if you see that here, so both electrons goes to one of the fragment. Both electrons goes to one of the fragment here. Base case homolytic cleavage, if you see that each fragment will get one electron, and whereas here each electron goes to, both electrons goes to one of the fragment. Next, retro Diels reaction. So retro Diels reaction, you can call it as elimination reaction. Elimination by multiple sigma bond rupture, here retro Diels order reaction. Here if you see the example, so the cyclohexene, you see that it undergoes the fragmentation, so and it gives the diene, and dienophile. So two things you will, so this can be by two modes, that is one electron mechanism or two electron mechanism. So retro ordered reaction is opposite, reaction of Diels order reaction. So where you, here in retro Diels order reaction, you will have the pair of or cleavage of multiple sigma bonds. That means here two sigma bonds will be cleaved off, and you have the formation of three double. How many double bonds are there here in cyclohexene? One double bond is there.
One double bond.
How many sigma bonds will be cleaved? One, two. This multiple sigma bonds will be cleaved, and multiple double bonds will be formed. So, and this can be of one electron mechanism or two electron mechanism. This is retro Diels order reaction. So, in the first thing what you have discussed, that is general under the simple cleavage. Under simple cleavage, so you have the homolytic cleavage, how a molecular ion can undergo fragmentation, that is by homolytic cleavage or heterolytic cleavage or retrodyl order reaction. Next one, that is rearrangement reactions. So here rearrangement reaction, here it is that, okay, so there will be transfer of atoms. So under that we have the scrambling. Okay, so for example, if that in the scrambling, for example, last class we have discussed that in the is if you have alkyl side chain to the benzene, what happens? So here if you see that the alkyl side chain when you have to the benzene, so it forms the troponium ion. So the example for scrambling, if you see that here, you see that there is a alkyl side chain to the benzene, and here we have seen the last class we have seen that when we are discussing the general rules for the fragmentation, that is the modes of fragmentation. There we have seen, suppose you have a cyclic aliphatic cyclic structure, and then if you have side chain to the cyclic structure, the fragmentation takes place at the alpha position, and whereas for the benzene, if you have, okay, side chain, the fragmentation takes place, cleavage happens at the beta carbon atom. So in this case, if you see that benzene is having a cyclic structure, benzene is having an alkyl side chain, and the fragmentation takes place at the beta carbon, and then it undergoes the internal rearrangement that we call it as a scrambling, and gives a 7-membered troponium ion. This is the example of scrambling. Okay, formation of troponium ion. Next one is the Mcclafferty rearrangement. Mcclafferty rearrangement is a transfer of hydrogen atom. Okay, so especially gamma molecules, if you have hydrogen, and this gamma hydrogen, there is intermolecular rearrangement, you can call it as a if molecules, especially if you have the molecules which are having the gamma hydrogen, so they undergo the Mcclafferty rearrangement. So here sorry. So this involves generally transfer of hydrogen atom from one part of the molecular ion to another part of the molecular ion, and so it can happen in the various molecular ions. So here you can see that is the example of Mcclafferty rearrangement, and especially this is ketones, and here you see that here the gamma hydrogen, okay, it migrates to the oxygen. And you have the fragment ions. Okay, fragment ions. So neutral molecule will be eliminated. Okay, neutral molecule. So especially the gamma hydrogen. Okay, the Mcclafferty rearrangement. So one part of the molecular ion will be eliminated as neutral molecule. Okay, understood. So this is a Mcclafferty rearrangement. In Mcclafferty rearrangement, to happen, the molecule should have the gamma hydrogen. If we have a gamma hydrogen, then the migration of the hydrogen happens, and one part of the molecular ion will be eliminated as neutral molecule. So this is by rearrangement, Mcclafferty. The basic requirement for the Mcclafferty rearrangement is that the molecular ion or the molecule should have the gamma hydrogen, this hydrogen. So it moves to, it migrates to the oxygen, and then you have the rupture of the, okay, you have the rupture of the sigma bond, okay, sigma bond, and elimination of, okay, neutral molecule and a fragment ion. Okay, this is the enol it is. So this is Mcclafferty rearrangement. So the fragmentation by Mcclafferty rearrangement. So here rearrangement is happening, and at the same time fragmentation also is happening. Understood here? Okay. Have you understood?
Yes, sir.
Anybody has not understood? So if you have not understood, you can ask the question. Anybody?
Some scrambling, sir.
Which one, madam?
Confusing. Some scrambling, sir.
Scrambling. Scrambling is an internal rearrangement. Yeah. So it is an internal rearrangement. You can see here. Okay. If 6-membered here, it is see that here. It is and this scrambling example I have given here, especially aromatic compound or this is benzene. The the side chain is alkyl side chain. If you have the fragmentation takes place at the beta carbon atom, okay, and then you have the benzylic cation. This is a benzylic cation, okay, and this benzylic cation, what happens? Internal
sir.
rearrangement takes place. 6-membered one. That 6-membered one will be converted into a 7-membered cation. 7-membered cation. So this is internal rearrangement. Internal
Okay.
6-membered is converted into 7-membered.
Rearrange.
Okay, this is a rearrangement. It is scrambling. And whereas
Okay, sir.
Mcclafferty rearrangement, it is a transfer of, okay, one of the atom, okay, from one part of the molecule to another part of the molecule. So here you can see that, so you have the gamma hydrogen. This gamma hydrogen is transferred from the carbon to oxygen, and simultaneously there is a cleavage of the sigma bond and elimination will be there. So in the previous one you can see that there is no elimination. In the rearrangement, if you see that, okay, here in this there is no
Yes, sir.
elimination. So the atom,
Elimination.
you see that CH is CH2, here it is included into the ring itself. Okay, so here fragmentation is there.
Yes, sir.
Fragmentation is there. And next one, if you see that in the scrambling, at Mcclafferty rearrangement, here elimination is there, and this elimination, and in this in this elimination, you have a neutral molecule. Okay, neutral. This is a neutral molecule, and this is the fragmented ion. Okay, so for Mcclafferty rearrangement, the basic requirement is that the molecular ion or
Gamma hydrogen.
gamma hydrogen. So these are the molecules which generally undergoes a Mcclafferty rearrangement. Okay, so aldehydes can undergo Mcclafferty rearrangement, and then ketones can undergo the methyl ketone or whatever the ketone can undergo amides, acids, and ethyl ketone, that is another ketone, or esters, alcohols. Sometimes alcohols also can undergo the Mcclafferty rearrangement. Next one is that elimination. So sometimes, okay, fragmentation also can accompanied by the elimination of neutral molecules. Okay. So for example, if you have that alcohol, readily it loses, okay, generally it loses the water as a neutral molecule, and you have the fragment ion. So you can see that here, this is which one? It is a butanol. So butanol, so it is a molecular ion of butanol. Okay, and then so you have the elimination of water and the fragment ion. So here you can readily you can see that, so the alcohol you loses, so it is fragmentation by elimination. Okay, here there is no rearrangement. The previous case also there is an elimination of neutral molecule or cleavage is there. One you have the fragment ion, another one you have the you have that okay, and Mcclafferty rearrangement, we have seen there is a transfer of hydrogen from carbon to the oxygen. And here if you see that, here also fragmentation is happening, but the fragmentation is happening by, the fragmentation is accompanied by elimination of water, and water is a neutral molecule. So you can see this example. So, and normally you have the water, carbon dioxide or carbon monoxide, or CH2 double bond CH2. Okay, that is also neutral molecule, diene, that is. So then this is the example how a neutral molecule will be eliminated and the fragmentation happens. Okay, so here fragmentation happens. So and we can represent that is m minus 18. Okay, that's you can represent in that way. And next one is that in the elimination, fragmentation adjacent to the branching point. Okay, so that is, this is elimination. You can see. Okay, you cannot see that. Can you see that reaction? Yeah. This.
Yes.
Can you see this reaction?
Yes, sir.
Yeah. So here also branching point. So next to the branching point, okay. So fragmentation takes place adjacent to that, and you'll have the radical and so that is elimination. So, and as I told you that here only one will be recognized and radicals will not be recognized or detected by the mass spectrometry.
Detector.
Yeah, mass spectrometry detector. Next, coming to the, we have discussed that, okay, so the types of cleavages, okay, so how the fragmentation occurs, and here we have discussed that, okay, alpha cleavage, that is homolytic and heterolytic cleavage. So how homolytic cleavage and heterolytic cleavage occurs? So here this is one of the example of homolytic cleavage, that is alpha cleavage. And in the alpha cleavage, if you see that alpha cleavage also is called as radical site initiation reaction. Okay, so and here what happens is that, so the this cleavage, actually in this cleavage what happens is that, so the unpaired electron, okay, so will, okay, so the unpaired electron move from the radical to the radical site, okay, here unpaired. So in this cleavage, so results from tendency of the unpaired electron from the radical site to pair up with an electron from the another bond to an adjacent atom to the charge site. So here this is the charge site on oxygen. If you see that the down reaction, if you see that it is a charge site. So and you have an unpaired electron. So this unpaired electron will have the tendency to pair up an electron adjacent to that. Are you getting my point here? So this is a radical site initiation. Radical site initiation means a radical will be formed. Here you can see that a radical will be formed. So in this, what happens in this is a molecular ion, and this molecular ion, and it is a homolytic cleavage also. That means homolytic cleavage, what happens? Each fragment will get one electron. So here on oxygen I have the, okay, positive charge, okay, and here I have unpaired electron, and this unpaired electron, what happens is it tries to pair up. How it tries to pair up? By drawing one of the electron from adjacent atoms. So, and this drawing is happening because of the, okay, this heteroatom is present, that is electronegative atom is oxygen is present. That's why we call it as a radical site initiation. And radical site initiation means a radical will be formed. You got here alpha cleavage. So alpha cleavage also is called as a radical site initiation reaction. So here in this reaction or cleavage, what happens is that, so the unpaired electron will try to pair up. So from the electrons, then to pair up the electron with electrons, the electrons from adjacent atoms to the electron will, one of the electron will move to the oxygen,
Oxygen.
and here this carbon will get one electron and this oxygen will get another another electron. So now the electrons are distributed equally, and then here what happens is that cleavage happens, and then you have the formation of radical and you have the formation of fragment ion. So this is radical site initiation and example for the here homolytic cleavage. Okay, so as I told you, in homolytic cleavage, what is happening? The radical site initiation, only one electron will be transferred. Okay, you got my point here?
Sir.
Yeah, have you understood this? Alpha
Yes,
cleavage.
sir.
Did you understand? So in
Yes, sir.
alpha cleavage is, you can call it as a nothing but, okay, homolytic cleavage. In homolytic cleavage, what happens? So equal distribution of electrons happens. So, and in this case, if you see that oxygen, which is having a lone pair of, that is unpaired electron, it tries to draw the electrons atoms. So while drawing, so one of the electron will move from here to here. Okay. So and remaining electron will be with the carbon itself. So redistribution of electrons and equal distribution of electrons is there here, and you have the formation of radical and formation of fragment ion. Since it is a, in this cleavage, alpha cleavage, since formation of radical is there. Okay, so we have the radical site. Okay, initiation reaction we call it as. Next, sigma bond. Normally, sigma bonds will have mostly sigma bonds will cleavage will happen. So in generally it happens in the sigma bond alkanes if it's saturated, okay, saturated one if you have sigma bond cleavage, generally sigma bond cleavage happens. Next coming to that is when we go to the actual fragmentation process of alkanes, we will see that. Next one is inductive effect cleavage. Inductive cleavage is example for heterolytic cleavage. So here in heterolytic cleavage, what happens is that so both electrons move to the redistribution. It is unequal distribution. In homolytic cleavage, we have seen that it is equal distribution. Whereas here in heterocyclic cleavage, that is inductive cleavage, also it is called as a charge site initiation. Charge site initiation. This reaction, if you see that, okay, the electrons, both electrons will move to the that is here the uncharged site. Okay, and then here if you see that in the previous reaction, if you see, you can see that from this carbon electron is moved to the oxygen and we got the here a radical. Okay, radical is formed. And whereas next reaction, if you see that, and here, okay, like both electrons will move from here to the oxygen. Okay, from here oxygen, both electrons will move. And now what we got here, if we see that in the previous reaction we saw the formation of radical, but here we have what is that? Formation of charged fragment. So charge site initiation. So that is the difference between, and again how it happens is because of the presence of oxygen, sulfur and nitrogen, and because of the inductive effect. Okay, so both electrons will move from here. Okay, both electrons, and you have the formation of charged fragment, and then this is the radical ion. This is a radical ion. So in the previous reaction, if you see that, okay, so here if you see the electrons didn't move from the bond next to the oxygen. Okay, so that is this is if we consider the first bond, and if we consider it as a second bond, the electrons moved from the second bond, electron moved from the second bond to the oxygen. Okay, and then you have the formation of that is radical ion and then fragment ion. Next, radical and fragment ion, sorry. And next one, if you see here if you see that, so the electrons moved, okay, immediate bond, okay, oxygen, the bond which is immediate to the oxygen, the electron is moved to the oxygen, and then you have the formation of a charged ion and a radical. Okay, so oxygen is now it has become a radical. Okay, and this one has become the charged one. So that's why charge site initiation here it is. So did you get this point?
Yes.
Yes, sir.
Okay, so radical site initiation and charge site initiation, the difference you should know that. So radical site initiation is the homolytic cleavage and charge site initiation is the heterolytic cleavage.
Cleavage.
Yeah. So then almost all that is a hydrogen rearrangement to a saturated heteroatom. Again, it is hydrogen can be rearranged to heteroatom, and that is especially that gamma hydrogen, and it is if you have alcohols. Okay, if you have in case of alcohols, the gamma hydrogen is there, means this gamma hydrogen can migrate to the oxygen atom. So that is one case. Rearrangement, that is transfer of hydrogen atom. One hydrogen atom will be transferred. In Mcclafferty rearrangement, we have seen that. Okay, ketones we have seen, right? The ketones, what is happening? Gamma hydrogen is moving to the oxygen atom.
Moving from
Yeah, that we that is yeah, that is 1,5 shift we can call it as a, and it is and saturated heteroatom. It can also happen. There, in the ketone, we have seen that is unsaturated heteroatom and double bonded carbonyl oxygen. There it happened. So, but hydrogen also here, it can rearrange to the saturated heteroatom like oxygen in case of alcohols. Alcohols, in the alcohols, if we have gamma hydrogen, then it can happen. Next one is double hydrogen rearrangement. Double hydrogen rearrangement. So two hydrogens will be rearranged here. Fragmentation happens, but two hydrogen, and it can happen in the same 1,5 shift also. There we have seen that only one hydrogen is migrating to the migrating to the oxygen. So sometimes here what happens is that in the case of even Mcclafferty rearrangement, so double hydrogen rearrangement will happen. So that is, you can see here in this case. So, okay, so first one is the first case I have seen is that here hydrogen rearrangement to a saturated heteroatom. So you can, sorry. So in this case, this is a 1,5 shift, and oxygen, and that is hydrogen is to the oxygen. This oxygen, it is a saturated oxygen. Okay, so both ways it can fragmentation can happen. Okay, so that is rearrangement by transfer of one hydrogen to the saturated heteroatom. Next one is that, okay, double hydrogen rearrangement. So this double hydrogen rearrangement, so you can see here, okay, this hydrogen is moved to here. Okay, this one will be removed here. This electrons will be moved here, and this electrons will be moved here. Okay, are you understanding here my point?
Yes, sir.
Hydrogen will be moved here, and this electrons will be moved here. Okay, so two hydrogens will be rearranged. Okay, and then you have the C2H4. So here you can see that what you have, CH3 and CH2. Are you understanding my point here? Okay. Did you get my point here? Hello?
Okay.
Yes, sir.
So if you see here, okay, so
Sir,
double hydrogen transfer, if you see that, okay, what I have here, CH3 and CH2. Next, if I see the fragment, okay, so if I see the
Yes.
fragment here, C2H4, right? So one of the hydrogen migrates to the oxygen is a different case, but two hydrogens will be migrating simultaneously. Okay, so that is double hydrogen transfer. Next, ortho rearrangement. Next one is the ortho rearrangement. In ortho rearrangement, you can see that here same, it is similar to the Mcclafferty rearrangement, but it happens from the ortho position. Okay, so you can see that in this molecule, one of the hydrogen migrates to the here. Okay, and you'll have the ortho rearrangement. Okay, this is ortho rearrangement, and next one is the cyclo inversion reaction. So cyclo inversion reaction, yeah, mainly occurs in the 4-member cyclic molecules. Okay, cyclo inversion reactions, that is fragmentation, how it happens. Okay, so next one is these are all we discussed. Okay, so general, so till now what we have discussed are, okay, so what we discussed till now,
Fragmentation rules.
yeah.
Fragmentation rules.
So in mass spectrometry, we have discussed that is, so the fragmentation process. So the fragmentation process, basic things we have learned, how a mass spectrum looks like and how it will be represented. Mass spectrum will be represented, and what are the types of ions will be produced in the mass spectrometry. And then we have seen the general rules for the fragmentation, and then the types of, that is fragmentation, that is how the fragmentation takes place, by what modes the fragmentation takes place. Okay, so up to here we discussed. So if you have, I'll post this in Google Classroom and you go through the things, and if you have any doubts, okay, and you can ask me in the next class. You got my point? So if
Yes, sir.
up to this you go through,
Yes, sir.
yeah, any of the, I will
Yes,
post
sir.
this in, I'll post this into the Google Classroom. If you have any doubts regarding this class or the previous class, and you go through the slides, and next class when you come, okay, you come with your points, and we will discuss. Okay, so with this
Okay, sir.
finish the class, and do you want to ask me any doubts right now? If or you'll go through the slides and you'll come with your doubts.
Yes, sir. We'll go
Yes,
through
sir.
and come.
Yes, sir.
You'll go through the slides and you'll come with the doubts. Okay, so
Yes, sir.
and mass spectrometry is very much important for you. Okay, so thoroughly go through the slides and come back to me. Okay, and tomorrow as usual you'll have the, maybe it was today a little bit late, and tomorrow as per the schedule we try to start the class.
Okay, sir.
Okay,
Okay, sir.
okay then.
Okay, sir.